The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kīlauea eruption update. Today, Friday, October 1st. You guys are seeing images from a short video we posted earlier of the first visible lava from public overlook in Hawaiʻi Volcanoes National Park. So that's our headline today. We're going to be discussing the latest monitoring signals in the volcano, as well as all the most current video and photographs, and we'll take viewer questions and do some discussion of that as well. And Dane will be collecting questions in our chats and manning the chats as well, answering what he can there. And also let him know if you have any issues with our audio or video. He'll be listening for that as well. So yeah, that's our big story today on Kīlauea, is that the lava has become visible from the north side of the crater. We anticipated this yesterday, but we anticipated a view from the opposite side of the crater, so we're actually totally wrong on that. The fact that it was visible from the north is just through a small little gap, and it's, maybe we got lucky there, but in any case, the lava did become visible yesterday as we anticipated. So that's these first views here. I've looped it for you guys, and if you want to watch it some more, you can pull up that separate 1-minute video that's on our feeds as well. All right, so let me pause this. And let's move on here to, oh, nope, that's not what I'm looking at. Here's our most current thermal image. So, the first thing I wanted just to show, we'll look at the thermal in more detail later, but just you can see that the lava lake is still active. The eruption is ongoing. There is really no change visually that you can see here on the surface, right? As far as like eruption stopping or something like that. So that's just the first thing to check, because we can't directly see much in there. We can only see that one little edge. And in fact, when Dan and I were up at the national park last night and we first spotted that edge of that lava lake there, it seemed like the rate of rising that we saw yesterday would have brought it even more into view by this morning. And it wasn't that much closer into view, and part of this is explained by what we see here on this depth plot by the USGS. So this was our crusted lava lake level, and so our initial filling was very quickly right here. We filled up that first 30 feet or so, right? 10, 12 meters or so within that first burst of the eruption. And then after that one point right there, I can zoom it in some more. Maybe you can see this better. And so after that quick rise right here, we've been on a slightly different, more of a curved slowing pattern, which is what you'd expect, because our crater is like a giant ice cream cone or a funnel, or it's basically a cylinder here, right? So the more layers you want to add to the top, you have a larger area to cover, a larger diameter, larger radius, larger area altogether to cover. And so each discrete amount, like if you imagine, one packet of lava and you just put it that same amount over and over again, it's going to cover less and less height every time, because it's having to fill a larger area and spread itself out, and so that makes it slightly thinner. So you naturally expect that curved pattern that you see there. And there are some variations within it there, and that's interesting to consider there. We can look at some of the other processes that are happening, such as, for example, we're seeing the edge of a perched pond start to form in a lava lake. That can start forming these shorter deviations and little wiggles you see that deviate from that general term pattern. So from last night, this was a trend. It was actually rising fairly slow. And it may have been that margin of the lake that we can see is fairly close to that perched edge, and so it may not have as much circulation or as much visibility depending on what's happening, right? You can see that more recently earlier today, we had a little bit of a bump, and we had a steeper rate of depth increase, so we had like a little surge, for example, at least in a very spot where this laser is measuring. It's only measuring one spot on that hole. I think it's... I have to look at the size again, 124 acres or 115 acres perhaps, somewhere in that range, lava lake, 115 acres I want to say. So that's the depth measurement there, which is essentially the filling rate, and let's make sure we reload it here to see that it actually is still gaining. It's just doing so much more slowly than it was even earlier today or at the beginning of the eruption. So the slower it goes, the longer it takes for it to rise into sight, and it's just kind of a longer drawn out process, as far as that goes. So that's the depth plot. We can refer to that later if we need to. I did want to refer to a USGS tweet here from a few hours ago. And by that point in time, they were measuring 24 meters, 79 feet of rise right there. And noting that the number of locations of fountains have decreased, as well as the rate of lava lake rising has also slowed. Right, so 24 meters, you can kind of see we started at 226 right in here. That would have put us at 250, so we're really up, looks like more like 253. We've gained another 10 feet or 3 meters since then. And so as an estimate, we're probably somewhere around 90 feet and 27 meters would be a estimate right now. All right, and just to make sure we cover the source of all this information, it is the USGS, and we're using all this essentially fire hose of images and reports and videos and webcam captures and all this stuff to try to narrate the story for you guys, essentially. And they're putting out all the source of this information. And because we're having daily updates, we want to make sure we cover that here, and maybe I can enlarge this a little bit so that if anyone does care to read it, you have a chance at that. All right, so we are at alert level warning color code red still. That hasn't changed. The aviation color red is actually, I didn't mention this recently, but there did impose an FAA restriction. So there is a restriction over the airspace still, and we'll see if that lasts, because You'd imagine that these first stages of the eruption are the ones that are the most unpredictable, and at some point, once it gets into a groove, you might think that you might reconsider those rules. So as far as I know, we still have the FAA no-fly zone here, so if anyone else knows otherwise, you can drop that in the chat and let us know here. Otherwise, today's update from earlier this morning, we're still erupting, multiple vents, seismicity and gas remains elevated. Now that's some of the new information here. SO2 rates remain high and were estimated around 20,000 tons per day in the morning of September 30th. That was yesterday morning. So 20,000 is a lot still, of course, but that's significantly lower than the 85,000 tons that was measured just after the eruption started within minutes afterwards on September 29th. So we'll look at the gas here next, and then we'll come back to look at the seismicity, which is still stable. A few earthquakes and ongoing tremor. Tilt meters are still doing slow deflation, and we'll look at that as well. Okay, lava lake observations. Lava continues to erupt from the multiple vents on the base and the west wall of Halema'uma'u. Though the number of active fountain locations has decreased over the past day, the rate of lava lake has slowed. Over the past 24 hours, it's risen approximately 4 meters, 4.4 yards, and in total 24 meters, 26 yards. And we just revised that, right? But it shows you that the first day was 20 meters, and then only 4 meters since then. That's part of what you expect with that slowing rate, as well as that combined first initial burst of lava that came out was really an impressive signal that it put out. They do note localized and discontinuous crustal foundering continues. That's the overturning process of the crust of the lava lake. And last night, field crews reported maximum fountain heights of 50 meters, 50 feet, we'll call it, at the dominant vent on a west wall. So now the dominant vent has become the west wall rather than the center of the lake, and fountain heights maximum 50 feet or so. Low fountain continues at other sources which are less vigorous. All right, the East Rift Zone has got a slight revision here. No unusual activity. And what they say here is that ground information motion suggests that the Upper East Rift Zone between the summit and Pu'u'o'o has been steadily refilling with magma over the past year. SO2 and H2S was below detection back in January. So the new sentences here has been steadily refilling over the past year is what they're saying. So we're not talking about any slowdowns or speed ups or anything like that. We're just stating that for the past year, it's been a net refilling. Hazards, a primary hazard is still gas, so we'll talk about the gas some more, since that is the primary hazard, and there's quite a lot of gas coming out, as we've just mentioned, and it is now impacting our communities on the south and western side of Hawaii Island. So we'll look at that as well. Okay, so let's move on from the text. I don't like to show too much text, but I think it's important to cite our source here. So here's our gas data. We're going to look first at this 1-year plot from the USGS. Well, let's look at the 1-month one down here first. So our background measurement down here, right? These are, let's scroll over so I can give you guys a scale. 0.2 times 10 to the 5th tons per day. So we're looking at 20,000 ton per day hash marks between here, right? And we're looking at a month in this case. So early on, we're essentially in the 500s or 100 or less kind of range. So basically a 0 there, and our first point in eruption was right here, at 85,000, and this bottom one is the most recent one at 20,000. So that's the monthly data. If we go back to the yearly data, you can see that these last 2 points really stack up almost on top of each other, right? And it really dropped very fast on this scale. And the reason I want to look at the year plot is because within the last year we had eruption at the summit as well, and we can look at the comparison of pattern there. So we also had near 0 values, spiked up quite a bit. We didn't measure exactly at the first minute eruption, so it might have gone equally high potentially before coming down, and you can see the tail of it. It took about a week for it to actually tail off. So you see there's a little bit of a gap right in there, right? That width is an important factor. And so maybe we'll put it a little lower just since we don't know. And then it basically erupted with low gas coming out for a while, and this is important because the gas output is a proxy for how much lava is coming out. So not as much gas coming out, not as much lava coming out. So this gas plot essentially is a lava effusion proxy here. And when we come to this eruption, you can see that we came up quite high. With that, we're coming down very, very quickly as well. And so with this very rough Madden pen on the screen here, you can see that the width of these of these peaks is different, and it appears thus far from that one single data point is all we have, that there is a chance this eruption could be dropping off faster than the one last year, right? And so interesting to note that. Scientist in charge, Ken Han, was quoted today as saying that a pattern of shorter, more frequent eruptions at the summit would be consistent with refilling the summit area following a 2018 collapse. And so he wouldn't be surprised if it was a shorter eruption and we had more frequent eruptions like we're having 2 within a year time frame now within the summit of Kīlauea. So that's the big picture with the gas. Let's scroll down and show you guys these ambient readings. Cone Peak, which is maybe halfway down a southwest rift. That's Sand Hill, which is closer to the summit on a southwest rift, close to the southwest rift. And then down here, we finally have had our calibration peak scroll off the left edge of this month-long graph here. And we actually can see this Pu'uko'ai, which is the furthest down a southwest rift station, also picking up as much as 8 ppm of SO2, right? We can see Sand Hill closest is up to 12 ppm SO2, and Cone Peak 5 ppm SO2, that midway point halfway down. So these values are getting significant. We can look at, oh no, come on, doesn't like to. This panel does not like to go into the background. It loses all its data every time. So if I don't load it fresh, it doesn't show us the data. So here's the data. This is the state of Hawaii air quality map here, and we're now integrating all different measurements of air, and you see these ratings, the greens on the east side of the island. And actually, you do see some greens right now in the southern parts, but especially you see the yellows over on the Kona side. You would imagine further south in the South Kona and all the way up, and we'll check on that. Waikoloa as well is showing levels of VOG, right? And we actually can filter this out. We can click on SO2, for example, and see that, well, SO2 actually looks in the green in most places, although it is still very high at Ocean View with 50. It's going to be borderline yellow, and Captain Cook as well, probably borderline yellow as well. You can check that by clicking on one of these and seeing right there, there's a yellow, and there's we're borderline yellow right there. And you can see the history of these areas as well. I won't go through all of it because I'll show you some other versions. But besides SO2, the other thing that's really affecting is the PM 2.5, and that's where a lot of these measurements come from. And that's because the VOG does react with the water vapor in the air and with the presence of the energy of sunlight to help the reaction. And you do form actual particles of sulfates that fly through the air. So the VOG is both SO2 and the PM 2.5, and you can see them here, kind of combined in this overall plot right there. That's the current air quality. We'll move on. I want to show you guys the national park map. Everything is green on the national park map as well. So anyone who's planning to visit the national park to try to get views of the glow or try to get a peek of that lava lake, you may be busy, you may have to wait in line potentially, but the air quality looks good close to the ground at all these monitoring stations right there. I will note, we'll look at this in the data down here below, but the national park does include both the Kīlauea section as well as the Kahuku section over here, and so there are plots further closer to South Point and on the South Kona side as well, and we're going to see that these stations are actually picking up levels of VOG today as well. So the park has this on their page, and I will just scroll down here and show you guys quick passing by, right? All these different place names: visitor center, SO2, PM 2.5, parking lot, and then you can see this is basically 24 hours, and these are all little green dots. Maybe I can make it bigger a little bit. Yeah, these are all little green dots. And when you see something that historically goes into the orange or yellow, like right here at Kahuku, then that shows you that there was VOG at that period of time at that location. So down there at Kahuku, we're seeing SO2. And going everything green, and it's been green all day is the point here that you can also see. And even Honau is green all day, but you look at Kaloko Honokohau, and there have been a couple hours in the afternoon of a little bit of PM 2.5 VOG down there. So that is real. There is let's zoom this out so this will function. There is the UH VMAP VOG mapping project, and they put out VOG forecasts, right? So you can just Google VMAP if you like. You get the VOG forecast, and here is the VOG forecast at present, with which combines both the output of the VOG of the gases and the current weather patterns and weather models. So you can see clearly we're having a trade wind pattern blowing from the northeast, and all this gas blows to the southwest. And then once it gets around Mauna Loa, it likes to wrap around here, and so it can often get trapped back behind these two big mountains of Mauna Loa and Mauna Kea, right over here. So that's the issue with the VOG on the Kona side, and the forecast does not look good. I hate to say it. I'm not the one breaking the news. Everyone has known already for a couple of days of VOG is, or if not a couple of days, at least all of today, the VOG has been pretty bad over there. So here's our purple air, and let's see if it plays nice. Purple air we haven't looked at yet this eruption because there is a sparsity of citizen monitors over here in this Kīlauea area in particular. But there's quite a lot on the Kona side. So you can see here these oranges and reds all the way up the Kona side, all the way to Kohala here.
We also had a little bit of an issue with those updating in the early days of the eruption.
Yeah, we sure did.
Getting points that made sense across the map. It would be just like one point would report in, then the rest wouldn't be updating. So it took it a little while to catch up. Right.
Yeah. So there can be a lag, and for example, that VOG mapping data has to have that most recent model run, right? So if you had looked this morning, you wouldn't have seen that same forecast as you do right now. Yeah, good point. And some of these stations, if you look, like this one up here to the north, that says 119. That one always is abnormal. I'm not sure what's going on there. If there's like something industrial nearby, or it's just a defective.
Yeah, it always reads around that number too.
Yeah. So that one you can ignore. But the ones over here we just looked at recently, maybe not purple air, but all these are all real measurements of particulates in the air there. So that's purple air. Let's close that. And I want to show you guys something posted to Tracker. We're going to look at a little bit more of Tracker later on, but an image of VOG over Kona. You can see that hazy sky there. That's the effect that people are seeing here, right? You'd like to see the sun on your...
Yeah, those sunset photos are going to get paused for a little while, I think.
Yeah, but it depends, because you can see someone here posting a comment, no, not so much anymore, so clear that. So it kind of depends where and when. But yeah, it is something to be accounted for nowadays, which you didn't have to. And
yeah, we have one person saying it's pretty bad in Kauai.
Yeah.
Saw somebody else saying it was pretty bad over where they were. So hit or miss.
Right. Yeah. So yeah, that's the biggest impact of the eruption is the VOG. So yeah, I'm not surprised to hear that, and that's really what we have to work with today. Unfortunately, that's it's better than having lava go into communities, and it's also a lot more common. This is fairly common, right? You can imagine from 2008 to 2018, that was constant output of VOG that went to the Kona side. So it was really before that era that it was more VOG free. So it's really been a new decade and a half here of VOG on the island, right? All right, so let's what we're gonna do is we'll keep going through our current monitoring signals. We'll take a break for some questions of discussions, and then we'll kind of finish off with a slideshow of all the rest of the images and pictures. We will show you guys some of the live webcam views here coming up shortly, combined with the time lapses of them. So we will get to that. I see some of those questions coming in, and we'll look at some of the earthquakes as well. Those of you guys who are interested in that as well. Okay, so. Simon Karn at Michigan Tech, I believe he's still there, pointing out the Sentinel Tripomi SO2 capture as well. So right, that's another satellite view capturing SO2, and you can see here the red where the most intense SO2 is, and the dispersal cloud that actually in this view you can see wraps all the way close to Oahu, and it's not uncommon for Oahu to get VOG from eruptions on the Big Island, especially during these high gas phases. So that could be, give it another day or two, and you might be talking about VOG on Oahu as well. We can go to Windy, and Windy is also updated finally, and here's our Windy plot of the SO2 pattern here. So now it's detected, and you can see it's more visible in the context of other industry in China, and looks like Central America is slowing down its output from its volcanoes. And over here, Canaries are still putting out a huge amount of everything. So that is windy. Let's move on from that. And I want to mention the Volcano Watch because it has some of this data stuff we want to talk about as well. So I'm not going to read everything, but I want to highlight some of the points here that they talk about. And this is posted on hawaiitracker.com if you want to go through everything as well. But they point out some of the patterns of the initiation of the eruption here. So they talk about the intrusion occurred. We've been talking about that as well. Earthquake counts dropping to low levels and then increasing slightly on the 24th, breaking a 1 month quiet. The earthquakes began in Upper East Rift Zone beneath Pauahi crater just before midnight on September 28th. Overnight, they were closer to the summit, followed by a swarm by Puhimau crater. So that's all in that Upper East Rift connector, which is, we've talked about, could be considered almost part of that whole summit reservoir system, almost like part of the magma chamber. It's not exactly a chamber, but you know, the reservoir system, as we like to call it. Could be all connected in there with a very open pathway through where it doesn't have to push its way in and out, and it may reflect the pressure of the summit close to 1-to-1. So that area, where was I here? After a relatively quiet morning on the 29th, the activity abruptly increased under the summit at 2 p.m. 30 minutes later, the intensity, frequencies, and shallowness of earthquakes, coupled with rapid changes in ground information, indicated magma was moving upwards beneath Halemaʻumaʻu. And that's when they issued the alert. They raised the alert from yellow to orange. That was 3:09 p.m. And at 3:20, less than 20 minutes later, the eruption began. So I think we deserve to give the USGS a round of applause and some kudos here for successfully raising the alert level before the eruption, and then nimbly raising it again a few minutes later, because that certainly shows the progression of the process there, and that's reassuring to the public, I'm sure. So they, of course, with that orange watch, they thought that the eruption could be imminent, and that's why it's also so fantastic. The tilt meters began to record a higher rate of tilt during the 40 minutes preceding the eruption, a total of 11 micro readings at the nearest instrument. And after the onset of eruption, it changed to a steady deflationary tilt that is continuing still today. Immediately before lava erupted, uplift of the older solidified crust was seen in a few webcam image frames where the fissures open. We'll look at that in detail. The initial fissure cut across the middle of the Halemaʻumaʻu floor and is followed around an hour later, around 4:40 p.m., by a fissure with several vents in a western wall of Halemaʻumaʻu. Multiple active vents continue to feed the growing lava lake, and they have some rising numbers there. We can ignore those. The tallest fountains have been measured at sustained heights of 65 to 82 feet throughout the night of September 30th. That's the one out from the near the southern end of the lava lake, but out of the middle of the lava lake, which that was that dominant fountain early on there. So, and here is some of the important stuff we're going to get to as well. A preliminary calculation of average eruption rate so far was approximately 120 cubic meters per second, 4,238 cubic feet per second, and I think I calculated that was close to, 32,000 gallons per second, Dane? Something like that. But that would have been the peak value.
Yeah.
Yeah, so
20, what was it, 26, I think?
I think 26 was quoted. 26 works out to 100. So if you really go by 120, it's slightly higher. It might be somewhere around 32 or something like that, yeah. But that would have been the peak value, as you mentioned earlier, and it's likely tailed off substantially since then. So they mentioned that the rates are accompanied by huge releases of volcanic gases, and that's why the 85,000 tons. And here is that sentence I'm repeating. The opening phases of eruptions can be unpredictable before eruptive vents stabilize. Right, that's the reason for caution here, and I think this is an insight into their thinking as far as how the process goes for them. So that is that, and we do have a couple of maps that we'll look at here, and we'll look at them a little later as well too. But this is a thermal map, so this is a false color image, of course. The blues are the colds, and the yellows and reds are the hots. So the vents are in red there. You can see here, here, and here. All through there. You see a little bit of red and the cracks of in between these plates of the crust in here. That's likely an area where we're starting to see that crustal foundering, overturning. area, you know, where you see these red veins, essentially. And this is another little islet, a little piece of the older crater floor that's sticking up through the lava, which tells you that the lava isn't that deep through here. We did see this thing get covered all the way in lava earlier on, before it appeared that the whole floor of the crater together has started lifting up as a piston head. We'll look at that later as well. But that's the orientation here, right? This is our island. We can call these our central vents, and our southern vents, and our western vents, just so, you know, if I can use those terms to talk, we can all be on the same page here. Right, and now we have our regular update there. So you can check hawaiitracker.com for the full article there. So recapping what was just mentioned, earthquake rates over the past month, that seismic swarm and intrusion ended on the 30th, so that would have been somewhere back over here. This is that month of quiet. Here's where the quiet was broken. And here was that swarm of earthquakes that led up to the eruption. And since then, as far as a raw counts of numbers, you can see that we've dropped down substantially as far as earthquakes. There are still earthquakes happening. We're not at 0, but they're down a lot. Okay, so I did see that question come up. So that's there's the answer. We'll look at it in a little more detail, but that's the general pattern there. And over the past year, where you're looking at earthquakes per week rather than per day as we just were, you can see that we are still counting the beginning eruption earlier in a week, and we won't really see any resolution on that further on, right? So we can't really use this quite as much. All right, and so let's see. The tilt was also mentioned. So here is that rise in the tilt. We'll look at the past week graph. The rise in the tilt. It might have jerked down and up. So there's that rise in the tilt, and then the slow, gradual deflation, slowing deflation ever since. And here in this 2-day plot, you can see that we came down very steeply. We're starting off at 13 microradians up here, and we got down, we crossed 0, right, within, what's that, 6, 12, 18 hours. And in the 18 hours since then, 6, 12, 18, we've dropped down from 0 to, well, maybe -3 or something like -4. So it's definitely a slowing deflation rate there. And it hasn't quite flattened all the way out, but this is something that's interesting and perhaps more telling than the actual lava depth and lava levels. Lava levels are influenced by the geometry of the crater itself. The tilt of the ground is responding purely to the pressure that's putting the lava out. Right, so this is more interesting to me to see this thing flattening out than it is to see the depth curve turning over. And so there's not a whole lot more to learn from the tilt other than that. For today, here's our long-term pattern over the last month where it was inflating, rising. So even when we didn't have earthquakes in the lead up to this, we knew that there was pressure building and it was just a matter of time. And then since then, you can see we're starting to relieve that pressure. And it wouldn't be surprising if it came down still substantially more, right? But slowly. All right. GPS is still not giving us resolution. This is a whole year plot, and you know we're looking at one data point. So there's only 2 green or 2 blue dots here. It's really not anything we can look at for eruptions. The GPS is more interesting to us in between eruptions, where we're trying to figure out what's happening when we don't have the actual lava coming out to look at to gauge as a barometer of the actual eruption. Okay, so we'll move on from GPS, and we'll finish off here our first segment before we discuss some other questions with the time lapses, right? And we'll start with the F1 thermal camera, and mahalo to Bob Martin for collecting, and to Dane for collecting, and to Dane for producing this time lapse here. And so I'll start it up here. I want to zoom it in and let it run and start to point some things out here. So not a whole lot of temperature change on the side. I'm just going to ignore the temperature scale there and show you guys here. This is from the beginning of the eruption. So we see our middle island there. Right, it was the high point, was totally surrounded by lava in the beginning. In the backside, only one islet reemerges. All these other shorter ones are all still buried underneath the lava over here. But we do have also another feature sticking out closer to the camera. This is the the 2020 eruptions west vent. And so that's the old west vent cinder cone, technically speaking, right? The material of the cinder cone, which is now being added to by the lava flow of the lava lake. And so that's the features here. From the direction we're looking, our western fissures that are active now are down over here. So that's why you see So early on, the first fissures were over here, right? So that's why we see the first lava flows coming out, flowing in this direction there and there. And then once this western fissure activates shortly after that beginning phase, now we see the circulation come out this way. Apparently something like that, right? It looks like this one is putting it out over there. You'll watch this turn here. Here it comes. And from this, it seems to flow, kind of join it right in there. You see a little bit of a line of a divide there of the meeting of the fluids, right, from different vents. So there's a lot of different details going on here. So that's the first few of where the vents are coming out. We can notice also that there's a lot more vents at the beginning of the eruption, and they're much more vigorous, especially here in this middle part. Let me zoom into that, and as the animation plays on, you can see that they become much lower. They're no longer bubbling through there, and you see more of this purple-colored, slightly cooler crust forming in those areas. And so that's really fascinating to see, and that does beg the question. This may come up at some point, but lava coming up through the bottom of the lava lake, right, has all this overburden, all this material over top of it, trying to plug it back in. It's like it could all flow back into a crack if allowed to, if there was enough pressure pushing out. It's a little bit different with the one that's above the ground, like this western vent. But you can imagine that as this lava lake deepens and you add what's so far been estimated to be 10 million cubic meters of new lava into this pit, that at some point you may equilibrate the pressure downwards with the pressure trying to come out. And if that's the case, those lower vents may have a chance to shut off, and you may be able to refocus out of a different nozzle of the same blade of lava, or related blade of lava, that's a little higher up. And so that'd be curious to see. This is not that much higher up. Several meters is all I've seen so far. But it is enough to make a difference. As we saw, in the tail end of the last eruption, that last few meters took a couple months for it to actually be able to close that off. All right, so that's one layer of things we've gone through already. Let's look over here at this left edge, which I've ignored so far because I can do this in the same kind of time. But what you see here is now you see a distinct line, right? So early on, you see lava's going all the way to the edge of the crater walls, and it's rising and circulating and flowing and moving all the way to the edge. Now, right around here, you start to see a little bit of an edge forming, and that's the edge of the perching of this pond. So what happens is all these slabs of cooled lava on a surface, they're very hot still, but they're solid, are rafted by circulation towards the edges of the pond, and then they end up stagnating and getting stuck and stacking up, and it essentially forms a berm, and that can pond lava behind it, and lava can raise up and kind of stack up, and eventually it raises itself up like an above ground swimming pool. It's something that we saw in the last eruption. It's happened at Pu'o'o. It's a common thing that happens at lava lakes all over the world. And interesting to see here, just a couple days into it, to see this perched rim starting to form already. And this is the northern edge that is visible right here. It may be that the camera angles aren't ideal to see it in other places, but you do start to see a little bit on this edge here as well. And once you start to have that edge form, you can have overflows from this upper surface that go over top of it and occasionally flash different patches of color on the edge there. So let's see if I can zoom that in. And you can see here the edge starting to form right there. And now you start to see some of these little lapping flows come out right through there. All right, so that's a good amount of the F1 camera. I'm not going to overkill it here, but there's one last thing I want to point out here. And to do that, I'm going to manually drag the speed here and go really fast. Right, so you can really see the effect of the filling of the lava lake and a moving up and down of that island. Right, and if you notice, all the islands, this one is moving upwards, this one is moving upwards, and this one is moving upwards. This one down here is interesting because it might be moving upwards and expanding a little bit different than the others, but because it's a looser pile of cinder that was essentially the west vent cone that hasn't floated in lava lake yet. This thing floated in lava lake for a long time, as did that thing. Maybe this one can still has some void space that the lava can inject into and deform it and augment it a little bit. Would be one possibility there. So Let me drag it back and forth some more. And a couple of things to notice, right? You can see at first everything is buried, right? All these little islets at the back are all buried. And even this big island, you can see it's going to have a high lava mark right there. And then it pops and starts rising out. And so you see that slightly pinkish edge here on the edge of that block is the piece of the island that was submerged that's now rising back out of the lava. Right? And it's likely, well, maybe not likely to me it seems like, but my speculation is that that entire solid crust is acting like a piston head, and so the magma pressure from below is pushing it upwards, and it's now able to not just erupt fountains through the cracks in it and through the lake, but also push up the whole thing itself, right? Because it has become essentially loose and detached from the crater wall where it was previously frozen to. So that's all. I'm gonna beat to death an F1 camera.
Can I add a question a little bit about that?
Yeah, let's do them.
If it's nobody's questions written this one, but it's kind of mine, is if it is coming up as one individual unit or one mostly individual unit, why would we not be, and it's come up what, like 8-10 meters at this point, maybe more, that plug. If it comes up that much on that plug, why aren't we seeing the lava come around the edges of the crater?
The edges,
and squeeze out from
down here.
That plug's coming up, right? The plug's coming up. Why aren't we seeing the edges of where the most of the activity is happening? More distributed than focused into one or two points.
Yeah, that's a good question. It could be that I've mentioned it as a coherent piston with a crack in it, but you may actually have like several larger sub-blocks that are able to move independently is one possibility. That whole perching effect on the edge, it could be that the lava is cooling there more quickly and that's able to plug it up. It could be that whole piston head isn't actually like flat. It could be bowed, it could be curved where it's being pushed upwards in the middle by the pressure of the fountain. And that's causing a different kind of effect. And, but your point is a good one because that certainly is a possibility. And it's something that we've seen in the historical eruptions where we've had that epimagma plug where we've seen these kind of ring flows come up. And, in fact, at the end of the last eruption, after this perch pond developed and started forming gaps over here, we did start to see that as well. So it may be that we don't have enough resolution to see it here, or maybe the perch pond hasn't developed quite enough yet, or hasn't plugged it up enough yet where it can still flow up and out. But good question. We'll have to watch and see.
Yeah, definitely.
Look for clues on that.
I'll throw in a few other questions while we're here. Joseph asked about the west wall and those fissures along it. Will they be drowned out and plugged as the lake rises so it cannot produce any more lava from it?
That's a great working theory. That's what happened twice during the last eruption at the summit. But once again, we'll have to wait and see, right? If for example, you can start to backflow lava down the crack somehow from the lake and somehow plug up that pathway or block the pathway to that upper vent from some lower passage, then maybe you could disrupt that whole process. So there's a lot of unknowns about the geometry of the cracks underground, how they all connect, and how the plumbing system actually works, but that's a good working theory for sure.
We have a question about the cracks that were in the solidified plug in the lava lake before the eruption. So were those cracks the result of magma rising and forming a fissure line, or did that line already exist and the magma just exploited that weakness?
Those cracks were there already, and it seems like when it was early January, maybe it might have been January, I want to say 10th, that back half of the lava lake all crusted over coherently all together. And maybe I should show that the next time I pull it up. I don't have it lined up right now, but the whole back half froze concurrently. And then this other part over here, we had lava coming around this island and kind of flowing into a trench here for a while. And so you basically had partitioned that crust into an area that was older, and that might mean thicker potentially depending on the dynamics, and an area that was more terraced and was more gradually retreating, right? I mean, this all crusted over all together within, I'll say, about a day, more or less, and the whole rest of it crested over altogether over the next 3 months is what it took to get all the way to retreat to be all the way closed off.
All right. We do have a question here about this is a common question that we've had many a time, but it always pops its head back up as Sandra asked, does the increasing mass in the lava lake induce any weakness into the integrity of the crater itself?
We don't think so. We don't think that there's any coherent void space that you could collapse into like that. You know, maybe in a minor scale. There might have been some earlier on, but it seems like prior to the 2020 eruption, there were gravity signals of that void space being filled from below by magma. So it probably is still finding all kinds of little nooks and crannies in there. But it's not like the whole thing collapsed at once, talking about like a little rock here or a little bit there, or, you know, this whole thing is quite large, you know, over 100 acres of area. And the answer we've given before, of course, is, you know, the reason most of that space is likely gone is because you had a giant agitator, which is like something that geologists use to you can like scoop a bucket of dirt and you can put it in an agitator and it'll sort it all by different sizes of particles of your grains of sand or rock or what have you, for example, right? You just shake it. It's like shaking a can of nuts. All the broken nuts go to the bottom and all the big whole ones float to the top, because that's how they can work their way through that pile of stuff. And having had, depending on how you count them, 60,000 to over 100,000 earthquakes during a collapse of Kīlauea summit in the 3 months of 2018 in the summer, we expect that agitated much of that and filled a lot of that area below. So we don't think that there's a huge amount of space, and what space is in there all survived that entire process of collapse, and so it's coherent enough where we can't really collapse it so much, and maybe you can fill it with magma from below, kind of thing. But overall, it does seem to be coherent. It's more about the movement of the big blocks that the magma is moving through and around. Like, you know, if those get pushed, like the south flank, if it gets pushed in a certain way and it causes a big earthquake, now you change the dimensions, the geometry, how much room is available in those reservoirs underground, and now you can start moving magma from here to there and having unpredictable things happen in a short term. So what you're looking for really is signs of other big earthquakes around the area that this thing is triggering, rather than it itself from its own weight causing further collapse and that kind of thing.
We have one more question. We have a bunch of questions, but we have a question here about exactly what kind of, with how hot the lava is currently in the lava lake, what kind of metals would be melted in it at that temperature? What is the temperature that you would expect it to be at?
So the temperature usually of the lavas coming out of Kīlauea is in a range of just under 1,200 degrees Celsius. You might get, 1185, you might get 1170, depends exactly. But that's about ballpark. In Fahrenheit, I think that's around 2,200 Fahrenheit, more or less. And so it's cooling very, very quickly. It's losing its heat very, very quickly. The exact metals, I don't have a list in front of me. I don't have them all memorized. There's a huge laundry list of them, and it's most of the metals are in there, is what I would say. Right. Most of them. There's gold in there, there's lead in there, there's copper, aluminum, antimony, and aluminum, and there's pretty much everything is in there.
Yep. Steel's going to be above the threshold. Titanium will be above the threshold. Stuff like that. A lot of the cobalt will be above the threshold too, it looks like, but not many. All right. So
more questions? Go ahead.
Yeah, we can do one more and then we can move on.
Yeah, sure. Sounds good.
G asks, doesn't Kīlauea follow a pattern of filling the Haleʻimaumau crater with lava and then eventually the lava drains out through the fissures in the rift zone?
Well, I wouldn't call it drain out. It injects the rift zones, and rift zones are part of the spreading of the volcano. And I got to imagine that the lava isn't just coming out of the ground exclusively; it's filling a lot of that area underground as well, and that's why that's important. Because injection into the rift zone can put magma in the rift zone underground without having to cause an eruption. Now that does destabilize the whole system, and it does make it more likely to have a shallow eruption from some shallow pathway. But that's not necessarily one-to-one. Not every movement of the south flank, not every intrusion or east rift activity leads to an eruption. right? 1924 was actually a huge example of like a giant intrusion that went all the way across Kapoho. And, like I forget how many feet the coastline dropped in Kapoho during that event.
Over 10.
Yeah, over 10 feet.
Big.
Yeah, so 3 meters-ish. Yeah, so, I mean, and lava did not erupt at that point in time, at least not where anyone could see it. Maybe offshore or underwater, maybe. But even still, not detected. So, even with that whole sequence, you're not guaranteed to have an eruption. And the important thing that you mentioned in your question there was the eventually. And eventually, if you look at the Lower East Rift, the interval of that actually having big eruptions come out and cover the ground is, it's decades long, right? The Middle East Rift, it's only years long. So the Middle East Rift is much more likely to go. And I would expect at the long-term transition to more Middle East Rift activity, at some point. And then after that happens for a while, and the south flank starts moving or doesn't move and is able to jerk with an earthquake, then you can start worrying about the Lower East Rift some more, right? And of course, it is the East Rift. It is going to erupt again eventually someday, guaranteed 100%, right? That's, for some people, part of the allure of being here. For others, it's terrifying, and it's not the right place to be. So there's a whole... We'll plug later. There's a new video that came out today by Vice, and I thought it was really well done. That features Dane and a lot of Lower Puna community, and it talks about the people's attitude towards living on a volcano, living on lava, and that kind of thing. So why you would do that, and compared to what your other options, it might seem less crazy to someone else, or it might seem crazier to someone who's used to the lava in Hawaii. It's okay.
Definitely. We'll do one more question and answer segment. If we didn't get your question answered, just go ahead and repeat it in chat, and I'll try and get it in the next batch.
I see there's a whole conversation happening there with the pyroclastic flows of Kīlauea, right?
Yeah.
Depending how you classify them. For sure, you could say pyroclastic base surge. Definitely, absolutely, for sure. In fact, killed a bunch of people back in 1790, so that did happen for sure, right? It's a little different than other places because, well, we won't go down all of that, right? But we do have other talks about the 24 eruption. We'll talk about the 24 eruption explosion again, and we can revisit all of that then. But certainly the whole Ka'u Desert has got ashfall,
right?
And Koi Tefra talks about explosive explosions were more common than effusive eruptions for centuries. Before people were here.
If anybody wants to find out more about that, I'd recommend looking up our walk with Don Swanson down to the south side of the Kīlauea caldera and get into. He talks about some of the ash deposits that are there and some of the history. It's really brief, but it kind of gets you in that mode of some of the timelines with it.
Yeah. That's the OG researcher on these explosive eruptions, and who has published and essentially opened everyone's eyes to how frequently this happens. Over the last, you could count 2,000 years, the volcano has exploded half as often. Half the time it explodes, half the time it effuses. So it does a lot. We happen to be in the effusive phase right now, so we're not worried about that as often right now. But someday that'll be the phase again. It's not, we imagine that having to do with deeper collapsed calderas and water and all that. And that's why we had that conversation before the 2020 eruption of when magma comes back, will it have explosions? We got past that. We haven't had time for the water table to really, establish nearly as well as it did in the 3 years after 2018. So I think we're in a clear as far as that goes for right now. Right. And maybe that's all I'll say on that, because that is where it gets relevant, is how, what are the chances of this thing exploding? And right now, there's no signs of anything like that going on. Okay, so we do have a couple more webcams. Dane prepared the S1 camera here as well, and this is a fantastic mishmash of various USGS sources here, and it does include a little bit better sequence at the beginning of the eruption here. So let me play it and zoom in, and we'll let it loop through for you guys here. And of course, we do have different rates of capture, so it does adjust for that as well. But okay, so here we are. Here's those first fountains coming up just east of that island. The southern fountains are over here, and early in this video, you really can't see anything in the west over there, right? You can see all the circulation as well. I'll have to zoom it out because it's probably hard to follow what's going on here. But the USGS, because this western part of the vent is no longer showing on the camera, right? The lava lake rose too far and the geometry is just wider. You can see that they actually moved the camera, as Dane spotted and reported to us earlier. So that's interesting, and you can note that difference now when you look at the webcam. It's not looking exactly the same place. Look at the foreground with this rock right here, and you'll see it's going to rotate around. There it is. There is a rock. And we don't have nearly as many frames at the end, but as time goes on, depending on how long this lasts, we'll have the animation continue with that new perspective over there. So you can see the lava flooding out across the crater floor. You can see a little bit of this diminishing of the vents in these areas from the beginning. But we've talked about all that in detail at the F1 camera. So I want to show you a different perspective here from the south. So that is a southern perspective, and we can look in more detail at some of these other cameras later on. We're just going to generalize here and show you guys the B1 camera from the east, the last 24 hours automatic, not from the beginning. We'll spend time other days on these other camera animations, but here's a sunset coming right out the camera, and you do see a little fountain here in the south. And if I can zoom it in, cool, here you can see this perched edge of the lava lake right there. So there it is. And that darker black stuff is a more cool lava on the outside that's spilled over top of this. Right, and every time that happens, it adds another layer of veneer to the top of this barrier, this levee right here. And that allows it to perch higher and higher and higher, and that's your above ground swimming pool, or a hot tub if you prefer. As I saw some of you in the chat might prefer the hot tub version of that analogy there. Okay, so that's the current view in the last 24 hours. This camera does get totally washed out at night, so we may end up doing a daytime only sequence, images sequence at some point, because day images really are fantastic from this camera. That's right down there at that lowest bench level, right there. I'll point out just for now, it's hard to tell exactly right here, right? But the foreground right here, this is higher ground in this area here. And it goes back around, and that contour line comes back in over here. So this is like a little bay right here that when the lava does reach the edge of this crater to fill up, if it goes up that far, this is the spillover point right here. So this is one thing important about this camera to watch that we can keep an eye on, is that is the spot, right? And while we can't see directly the same view as can be seen from the ground up by Uekahuna, people were actually looking down through this little gap and through this little notch on the side of the crater here to see likely some lava somewhere around here. That's probably the area we're looking at from that area. That's the very, very, very edge of the lake. It might be right behind this rock down here or something like that. Or maybe it's over here given the perspective. It's hard to tell exactly. But that's the B1 camera here. And to give it a better perspective, here's a KW Western camera. And in this recent view, let me reload it because maybe I'll get... Yeah, there we go. Much better. Not a striped and sunlight crater. But here's that high edge, and then there is that drop down, and so that bay is essentially right here. And so this is the lowest spillover point. You can really see that right there. That's a spot that the lava is closest to that edge. And so when it starts spilling over, it's going to be happening here, and it's going to start lapping up further and further and further. Whenever that happens, whether it's this eruption or the next one or what have you, right? You can see it's starting to perch itself, so that complicates things as well, because the lava lake edge may not be at the edge of this thing. It might have to get higher in the middle and then spill over and flow downhill onto that thing. So it may have to be higher than that potentially for that to happen. So that's a cool thing to see from there. And otherwise, we can see still active western vents, still active southern vents, not nearly as active central vents, and really that couple northeast points we mentioned yesterday are really not even visible anymore up there. Okay, so let's show you guys the, oh, I'm going to click that. Show you guys the last 24-hour animation here. And even in the last 24 hours, you can actually, maybe it's more than 24 here. It looks like it's going back to all the way to the beginning, huh? But you can see the rise of the lava lake from that original surface crust right there coming up. I think I have this. This is the old video, so I can reload it and we can see more in the last 24 hours here. Oh, no, it is popping all the way back. Interesting. We're getting a slightly more, we're 48-hour time lapse now. Here. And there is that low bay right in there. Okay, we'll finish up the webcams and then we're going to say some thank yous. Here are other current views, right? Current views. Let's give this a reload because of the light is much better right now. You can see there's a sunset shining some yellow light on that rock in the foreground. That's interesting. You don't see that too often. There's a new view here. But now our S1 camera can see that western vent. That's the highest fountain, most active thing right now. You can see it is higher than the lake surface, but it's not that much higher than the lake surface. And here's our southern fountain and our central fountain right over here. E1 camera, we just looked at that. KW camera, we just looked at that. Over in the south, some other views of what Kīlauea looks like under the intrusion area in the South Caldera. Wide angle from the tower. Wide angle looking south from the tower. Caldera panorama. And the thermal camera, we've seen that as well. And looking down towards that inner edge of the crater from the tower as well. And looking from Mauna Loa Strip Road, you can see there is a little bit of gas coming out, but compared to what we saw when we looked at this camera last time, a couple days ago, there's really not nearly as much gas visually, at least, compared to what we saw a day ago, 2 days ago. So that is there, and so yeah, and this strip road spot is fantastic. There are some great pictures from Mr. Harry Durgan up on Hawaii Tracker with the Milky Way and the glow against that rising gas plume from here. Just really fantastic, really high quality stuff there. All right, time for some thank yous, Dane.
Yeah, we want to thank everybody that came to view this live stream today. Consider liking, subscribing, and sharing this video. We do have a YouTube channel. If you are on Facebook, check it out. It's Hawaii Pod, Hawaii PODD. That's where we go live on YouTube. If you're on YouTube, you should check out our Facebook group, which is Hawaii Tracker. So you just go on Facebook, go into groups, and search Hawaii Tracker. You'll find us. The Hawaii Tracker, we end up taking a bunch of photos from the community and putting them all up. So there's a constant stream of new information, new images, and stuff like that being posted by the community and by visitors as well. So we encourage you to check both of those out. We also have our own website where we do take monetary donations. If you're so inclined, we take them there. It's Hawaii Tracker. That's where we post all of our information when it comes out, and we put it in chronological order for you so it's easy to find. And it has that social media presentation, so it's familiar for everybody. You can also make an account and share content there as well. We are supported by a couple businesses. Want to shout them out just real quickly. First is Kaleo's Bar and Grill in the heart of Pahoa, and the second is Kalani Tours out of the Kona side. And they do volcano tours as well. If you're looking for a nice tour to be able to get up there, check them out for sure. All right, get into the last round of questions, huh?
Yeah, and then we have our essentially show and tell photos and videos from the USGS still to wrap it up at the end. Perfect. Yeah.
So we only have two, and I'll keep, if anybody has any more questions, we only have two new ones to add to this. First one Teresa asked, can you remind us where the Jagger Museum is in the webcams?
Sure.
Maybe it might be easier with a map.
Sure, and I did see another question that popped up here about the size of the lava lake. So what I'm going to do is I'm going to pull up this map, which shows the previous extent of the lava lake there. That might be too much zoom. But the first question first, where are the museum and where are the overlooks? So the new lake is not what you see here, but it's covering that same pit area. It's still right in there. And the Uekahuna overlook at the Jagger Museum is right over here. The museum itself is closed, but you can still drive all the way up to here, and then from here the road is actually closed. It shows a black line, but that's not really a road anyone can get to besides HVO in a national park. So here is Uekahuna. The viewpoint to look down into the pit is not far from there, maybe slightly more this way over there. And as it rises, you might see it from a larger area around, and so we'll have to wait and see how it rises and where you can actually see it. That ends up being the best view from the north, it turns out, because you look down through this little notch, that bay is right there. You can look kind of through there, that little gap, and you can see the edge of the lava lake right in there for now. Right in that area, will be essentially see it rising through there and then filling more and more area of the view from that point in time. The Kanakako'i overlook on the south is over here by Kanakako'i crater. Right over here, the road is also closed right there. So a big gate and closed signs to not go past there, and this road eventually drops off into the cliff, and there's giant cracks all throughout it there as well. So we thought perhaps you might have a view from Kanakako'i over here in the south. It turns out there's quite a lot of 71 and 74 spatter ramparts that block the exact spots you want to be looking at. So you can kind of see a little bit to the edge this way, a little bit to the edge that way, but right where you want to see is just behind the hump in the wrong spot. There was an old trail that's not really marked anymore, the previous trail to Kanakako'i, if you're local and you've been on that trail. Further up between the, like on the way down, you know, is another place to try to look, at least a good place to look for glow and that kind of thing, and different perspectives, and it's kind of magical no matter which way you look from. And one thing that I really appreciate is all the angles you get, you see the crater walls of different geometries reflected, and so they light up in different ways from different points around the caldera. So no matter where you go, even if you just see the glow, it's still really an amazing thing. So that's a part of as far as where things are, and the size hasn't changed that much, but we do have here 112 acres as that previous dimension there, and let's see if I can find a scale here. So 200 meters is what we have up here in the top right, and so we're looking at, oh, that's going to be hard to estimate, 1, 2, 3, 4, 5, 6, 7, 1.5 kilometers maybe, by 1 kilometer maybe, something like that. Right, so maybe a mile by 3/4 or half. That's a very, very, very rough estimate there. But that, until we get better estimates from the USGS, that's what I can use to answer that question.
All right. Oh, by the way, that was from our friend Nathan. He was doing a bunch in 2018. I'm sure you'll remember.
Mahalo, Nathan.
Trying to document earthquakes, so appreciate that. We do have one more question here. Is how high is the lava, since we're talking about the dimensions of the lava lake, how high is the lava now compared to before it drained in 2018? So we had the overflows onto the crater floor, or onto the caldera floor there. What level was that elevation-wise, and how close are we now?
All right, so I still have this map up, which I'm going to use it again, because underneath it there is this profile here, and that might be too much zoom once again, but so on this lower panel over here, let me change my color. Let's make it green or something here. So this orange line is the pre-2018 collapse. I'm making it green now. It's green/orange line is the pre-2018 collapse dimensions of the profile of the caldera. So there was a lava lake. It was up at this elevation right around here, right? And that puts it more or less at 1,000 meters. It's a little bit above 1,000 meters above sea level, right? The previous eruption got us from 517 up to about 750 or so. Right? We've added, we said 24, so we might be around 775. So we're right around in here now, is where our lava level is compared to, maybe just below this ledge right there, right in there, where this thing is still sticking out a little bit, even though now it's floating, right? But still substantially lower. We're looking at 300 meters,
about that,
250 meters, somewhere between 200 and 300 meters. So we're looking at 600-700 feet. It's still got a long way to go to fill that up. And as you can see by this profile, I've drawn our ice cream cone. I'm looking at just this lower section right here. I'm not even considering that once it gets up to the upper part, it's really like more of a soup bowl, right? Where it's really broad there. And you have a much, much wider area to actually fill before you can raise it up to that same level. So you have quite a lot of space there, and that's why this red volume from earlier this year was only 5% of the volume regained of the collapse. Right? So even with what we have now, we're still a long, long, long way from recovering that collapse. And while I'm here, there is another measure from 1,000 to, yeah, it's roughly 1 kilometer there in that west-east direction. still with me?
Yep. Sorry, I was just reading the comments.
Okay.
There was an interesting one in there for me. I'll show you later. So yeah, it looks like we are getting through most of the questions here. I'm trying to find one that actually works. We do have a 1999 super chat from Pardon My Piano that says, "I was on the Big Island just a week ago. Can't believe I missed the eruption by 3 days.
Oh,
Now I
man.
need to plan my next trip here, again. Mahalo for all the updates. We appreciate it."
Yeah, mahalo for that. Mahalo, yeah. Too bad, but yeah, that's the thing. You never know exactly when it's gonna come. I got a question I can throw in here, Dane, that we got. That kind of, I haven't read everything, but it comes up quite often. We have this question about why are all the volcanoes in the world erupting all at the same time, kind of thing, right? And
I didn't know if you wanted to readdress that one.
Yeah, so I actually happen to have here, let me switch to this. There was a little tweet thread going on here, from the USGS Volcanoes when they actually posted a red warning, and someone asks, "So I just started following, is this normal?" And Global Volcanism Program and Smithsonian, who are the authority tracking these things, who we refer to for this information, they come in and they say the number of current eruptions is at the high end of normal. However, the annual eruptions total is still a bit below average. There's still 3 months left in the year, though, so wouldn't be surprised to see new activity at a few more volcanoes. That is the official Smithsonian account there, giving us the real deal on where we are as far as eruptions, right? So they're all in places that are fairly easy to get to and get footage of. So that is a big part of it as well, too, right? Someone mentions here the unknown neuroscientist. The data seems to have changed. USGS comes in saying they're always updating the database, and GVP comes in and says they update the database every 6 to 8 weeks. So right now, La Palma and Kīlauea aren't shown as current eruptions, but they're in weekly reports. Usually no one cares, right? Suddenly everyone's looking at how they're actually telling their data for once, and they're like, well, here's how it actually works. So they got to confirm everything and review it and add it and all that. And so those kind of comprehensive catalogs get published every 2 to 3 months or so. Yeah. Or what,
right.
1.5 to 2 months or so there. So I thought I'd throw that in there because we actually had someone else answering it other than me.
Yeah.
And there you go.
I didn't know you had a secret key kept in the back pocket for that one.
Yeah, it's just yeah. And there's a
We
map.
have a follow-up from Nathan. We're getting down to the end of the question, so maybe call this the last one. So follow-up from Nathan. He says, "I didn't realize that the lava lake prior to 2018 was so much higher and so much larger and deeper. Do they know if the weight of the lava lake in 2018 ultimately triggered the eruption in the lower strip zone?"
Well, so let me clarify first the first thing here, right? So this is the profile of the caldera right here. So this is the caldera floor and Hale-Makamaʻu crater right there. And within Hale-Makamaʻu crater was an overlook vent. So this whole thing was like the spillover, right? And the actual lake itself was probably like that size. The lake was that size. It did spill over and actually paved most of that floor before that collapse. But it was also much skinnier than that, right? And so it was the buildup of magma at the summit, of which the lava lake was essentially like a pressure gauge of it, right? And so, but it wasn't the actual cause itself. The actual buildup, the most mass buildup was within the volcano, in the summit underneath the lava lake, and to the point where it was pushing up that whole column, quaking the whole east rift zone, a little bit the southwest rift zone, pushing Pu'o'o's crater floor upwards as well. All that was going on before the thing actually popped and collapsed. So the buildup of magma in general in the lava lake was expressing it, the lava lake itself not the cause, but good question.
All right. One last thing I did want to mention is that Bison News documentary that they've been working on for a while, but just got released today.
I'm not done, I still have a whole bunch of pictures to go.
My bad.
Yeah, no worries, no worries. Yeah, I know we've already gone for a ways, and there's times going on, but we're not quite in as much of a hurry today. I wanted to make sure to show you guys the whole series of USGS images here, right? So we've given you guys an orientation a little bit already as far as where things are. The southern vents down here, central vents, western vents. There's that large island, the old western vent, and the little islet that remains. That's all the things we can look at here, right? And now that you refreshed on that, we'll look at some of these pictures. We looked at the September 30th, a little bit more last time. But because they're updating these pages throughout the day, there is some stuff on here that we didn't show you guys, and so I want to make sure we do. And one of those is this video. It was released of the highest fountain in the south of the lava lake, which actually was released yesterday. I just didn't make it in. But there you can see that's that one that was peaking 80 to 100 feet or so over that first night. And erupting through the lava lake, right? And deforming, it's actually, you can see the buckling of that thin crust on the edge of that fountain coming up through the lake. And it could be that those pieces of tephra reticuli might be these lightest pieces of the highest parts of these fountains that get buoyed upwards with the gas and floated away. They probably wouldn't even look red in this image. It would look like a black or dark brown piece getting shot out of there. So that's one of the videos to show you guys, and let's see if I can get this to respond a little more. All right, we have looked at some of these. There's one of those pieces of tephra with reticulite in it we talked about yesterday. A collection of that. I'll pause on this one. Fantastic view of the whole crater there on that first dawn after the eruption began. And we've looked at these bubblings and this bubbling over there as well. So here we go. What happened was there was a whole dump of images as a result of the overflight of the volcano. So the scientists got in a helicopter and went up with their instruments and took a bunch of pictures, measured a bunch of stuff, and that's where all those the thermal maps are coming from, and et cetera, et cetera. So we'll look at some of these images here, and there are a lot. So we'll go through what we can. Okay, so telephoto aerial image. And this is that western edge right over there, vigorously fountaining. And the old west vent is seen in the foreground right over here. Let me zoom in on that for you guys if I am allowed. There, so there is juxtaposed, for anyone wondering how close to the old vent, here it is the new vent. There's your answer, visually speaking, right? We've heard this is about 100 meters. Presumably to this spot, about 100 meters or so. Right? You can see there's another vent a little closer in that's not nearly as active as that middle part of that western fissure right there. Okay, I'm not going to spend too much time on every single photo, so let's keep it moving here because there's a lot to go through. Now we're looking south. There is that large island. These are the central fountains here, and the southern fountains are back over here. And you do see some gas. Interesting to see this line of fume around the edge of this large island right over there. Right? So you can see that there's gas trying to escape. And maybe that's a weak spot where it's able to percolate its way through. Remembering that this pile of island here is a bunch of cinders from similar fountains in that very, very first phase of the beginning of 2020 eruption, when all that stuff was falling into what was then a pond of liquid water that had come and filled in the collapse crater following that whole collapse sequence before any lava came back and boiled it all away within an hour and a half. All that in more detail in our past updates. If you need to go back and look for that, I just want to recap and tie it back in here. Different view here. Here's our large island. In the background, our western vent. Central fountains pretty low here and here. Right. Let's see here. This does allow a view of the island itself because let's see if I can zoom it in here. Because these early fountains right over here did drop quite a bit of spatter and coat this island with new material. So you do get a initial view of what that looks like. It's not all coated in one big layer of lava. It's just more tephra that line on top of there. And it doesn't look like it's that thick in the grand scheme of things. It might be more of this brownish stuff compared to the white stuff that's been discolored by the gases that have been coming out of there since the eruption ended several months ago. We'll continue our show and tell here from the USGS. Here, telephoto imagery of the taken during the overflight, 7:30 a.m., showing the eastern portion. So this may be close to the area that the overlook is looking at. Right? Somewhere in here is where you can get that public view. And they're saying no widespread circulation, and that's what's helping to limit the foundering and form the levee over here. Right? So we mentioned that before. As we looked at the thermal, a lot of this levee forming and lava flows being able to spill over the edge and down over there. So we'll keep going because The USGS has been snapping pictures. So now we're looking to the south. Here's our southern vents. This is the one right against the edge of the crater that is a little bit less vigorous, but it's been persistent. And this is a spot that used to be fuming and glowing a little bit on the crater wall for a while after the eruption was over, in fact. So we knew it was a hot, weak spot already, and maybe that's that cracked area that propagated across here, this old crusted surface of the lava lake, to allow this most productive early fountain in the south, the one that was the highest one early on, to come and burst through there. And we'll keep going on. I'm trying to scan the images here as well. Here we have telephoto image with the rainbow, and we'll see the rainbow again in a video coming up. But you see there is that center fountains, our line of fume, our back western fountain, all that is just another view of that same thing. So we will keep going. Okay, we are looking now at the, not clear over here. This must be that southernmost along the edge, and it's the southern productive fountain. And this is the southernmost one of the central fountains with the island off to the side right over there. That must be the perspective there. This one I may have to come into to see it in any decent resolution here. All right, so a little broader view. Looking from the, where are we now? We're on the east, maybe northeast part of the crater. So there is that island, the southern fountains, central fountains. And this gives you a little bit more of the perspective of how far down in it the crater actually it is. Right? So it's very deep along this backside. The low spot from this perspective would be down here, this little wedge right here. Okay, so let me close that one and open that one. We don't want you yet. And come down here. And more multiple vents. I'm not going to blow that one up there. We'll just keep going. And another wide view there. Maximum height yesterday was observed to be 80 to 100 feet high, mostly only a few meters high there. It's all same information repeated once again. And another nice aerial view, a little bit more of a vertical view looking down. See the rainbow coming through again, the distribution of fountains in the center, and that western one. And then this overturning crustal foundering cracks glow through the cracks here on the eastern side, just below the camera. All right, here is a second video of the overflight, and this is similar to those rainbow views you guys have seen, so a little bit nicer to see it actually moving here as they're flying through and rotate around the crater, looking down from the eastern side. Western vents at the top of that lava pond right now. And we're coming around. You can see the island. I can see quite a bit of fume still coming up at that point in time, early in the morning yesterday. And then here we have a more of a eye level view. It's hard to imagine the size of these things, right? That's the one that was 80 feet tall or so. So even the other ones that look like small little bubbles, if you're next to them, would probably be taller than you are by 2 or 3 times. Here is a thermal image released from the overflight as well. So a different perspective from our F1 camera, looking from the southeast now, and you can see everything labeled here. Drowned previous western cone, new western cone, southern fountains, island. Nice to see it different perspective as well. And this one we saw before as well. That one's also generated from that scan and flyover, right? And they use structure for motion software as they fly around to turn this into digital data that they can then use for many different purposes, right? Volume calculations, etc., etc. And look, here's the answer to our question that came up earlier. I thought I might find it here, but the dimensions of our new lake, of a new lava lake, are 980 meters, or 1,070 yards east to west, and 710 meters, or 780 yards north to south. Right? So let me maybe say it again with just one or the other, right? We'll do meters first. East to west, 980 meters. North to south, 710 meters. Or in yards, east to west would be 1,070 yards, and north to south would be 780 yards. And so think about it in terms of football fields. They're maybe not exactly 100 yards, but ish, right? So you're looking at 10-ish football fields going left to right, like that. And so that, you know, and up and down, you're looking at, you know, more like 5.5, you know, or six, something like that. Right? We do have some. It's been a while now, but we did have some size comparison posts that we put up during the last eruption. Right? People were asking about compare it to an airplane, compare it to a cruise ship. So we did that, and that might be something to pull up and share, Dane, for people who want to know more size dimensions. We might have a Hawaii tracker post or something from a while ago. I'm not sure how easy that is to find.
Yeah, I'll look at it. No promises.
Yeah, you're right. That does exist somewhere though. Then we can maybe redo it someday if we get ongoing imagery here in dimensions from the USGS on this. The estimated area of the lake is now 127 acres. It says here. So 127 acres, 52 hectares. Well, there's some real stats from the USGS, Mahalo USGS. And then here, with superimposed on a satellite base map. So you really can see how it's all contained within that innermost pit of the crater right there. And once again, compared to the overlooks, right? There is a Jagger overlook, Uikahuna, right there. And why you can't see, yeah, so that innermost crater is about this size right there. That next layer of soup bowl is like right that. And then the whole caldera goes beyond that, even further than that. So we're not going to worry about that, of course. But first, the innermost cone right there, that's the edge of it. So our little bay I keep mentioning and talking about, that's this little sliver right here. And like a ramp that comes down here. And so that's it right in there. And see if it'll zoom out for me here. And then one last one on this page here that was put up is a time-lapse sequence showing the opening sequence of that eruption, Haleʻimaʻumaʻu, with the S1 camera that we looked at a little bit before. And you can see that they actually rocket back and forth here because, I don't know, I'll zoom this in so we can maybe see a little better. They really want you to see this edge of that island wiggling like a loose tooth up and down right here. I'm not sure if this is zoomed in enough. So I will look at it blown up just one more time here, but just so you realize this is only showing the first 10 minutes of eruption there, and showing how quickly lava flooded all the way across. If you look at this part of it here, how quickly lava flooded across this eastern section of the lake right there. Okay, let's close that tab. I think I'm having too many things going at the same time here. All right, so a little higher res here. Now I can zoom into this thing enough so you can see this corner of this island, especially wiggling up and down. And hard to see when it's going on a slow frames at first, but let's let it loop around here. You know, it's all behind a fume as eruption progresses, and all that initial burst of 85,000 tons of SO2 gas comes out. Okay, here's our section right there. There's a wiggle. Very subtle. Original line moves. Right there. So that's the tipping of the ground just before, and you notice right over here, this crack starts steaming as well. Can zoom it in more over here. We can look at more of this area. Deformation and slow motion. There is that big crack that exists. Oh, no, that's the shadow of the edge of the island. And here is a series of cracks that exist between that older solidified eastern portion and that less old western portion there. So you can see it's right along this edge of the crack that the steaming begins, and then when a fountain comes up, you see the fountains here and here right out of that same exact crack. And this is the best view we have, and I want to make sure we just pointed that out in slightly more detail right there, because this is the most obvious it's going to get right here. All right, so that's what I had promised Marin yesterday, so I finally got around to it here. Okay, so there is another release from today, and I'm going to give us a refresh right now, because as I said, they will post things throughout the day and make sure we have all the information on here. So scrolling down, view, looking at the broken center line of the old road that collapsed in the crater there. and the lava lake from that perspective there. We have lava fountains creating waves or ripples in a lava lake surface. And so let me get this going for you guys here. Let's zoom it in. All right, the source of the fountain is down here, bottom left. You can see some of the spatter falling down. So the source is over here, and you can see this undulation, like waves. They say like in a crowded wave pool, inner tubes in a crowded wave pool. Is there their analogy? And see if I can get it back. I didn't. These things don't loop, but I just want to show you guys the waves, the ripples are pretty cool. It's something we've talked about happening during a Kīlauea eruption. And you know, there's even art of Pele surfing these lava waves. This one might be a little bit too small, nothing's breaking there, right? But you definitely can see there's like a swell like moving through that ocean of liquid rock right there. I definitely wanted to point that out to you guys. Okay, let's move on. Let's move on here. Another overview picture during the daytime. And they're pointing out here in this one what's visible, the western fissure, the center island, and that small islet as well. But we've looked at that already. I'm not going to zoom that in anymore. Here, this one maybe I will. This is the closer in view at that island that got coated in spatter. So there it is. That's a different perspective. All the lighter colored stuff probably has mineralization from the gases coming out through there, and all the other darker stuff is that newer layer of coating, right? The fissure coming and spraying onto here from the side. And maybe you can map out very roughly, you know, the edge of this thing, maybe up to here, but not as thick perhaps. It can be thicker in areas and thinner in others, but you can see where there's no white on this big block is likely where it got covered significantly with spatter. Okay, let's move on from there and read the caption, because the caption is important in this one. Measurements by field crews indicated that the highest point on an island is 8 meters or 26 feet higher than it was earlier this month. Since it is unlikely that the deposit of new spatter and tephra is actually this thick, the measurements seem to indicate the island has lifted up and is floating within a lava lake once again. So, no surprise for you guys who have been watching us for a couple of days now. We've been talking about that for a couple of days. And we are seeing the USGS talking about it here as well. I haven't seen them mention this anywhere else yet. Not that they need to, but I haven't seen it. Okay, scientists making field measurements. Here are all their tripods, all the different cameras and gears, and you guys are working hard all hours of the day and night. Having to, I know how much people dislike having to wear face masks for a long time. These guys having to wear gas masks for their entire shift the entire time. Imagine that, like every day of your work, right? That's normal for a gas geologist and eruption responder. Not to get out into the weeds there, but it's interesting to think about that a little bit. Here is the line of linear fissures. Those central fissures on the edge of the island, big island right over there, it looks like. And a closer view at that western vent, putting out spatter. They say that this view is from the south, look to the west, approximately 15-minute high fountain measured, right, over that 5 minutes. 50 feet high fountain right here. So maybe if this fountain is 50 feet high, maybe this gives us an idea of more or less the elevation above the lava lake surface. This is the best thing we can actually go by. Although I see some fountain pieces all the way up here, that's not going to have to count. So we know it's going to be less than that, right? It's less than 15 meters between this fissure and a lava lake, and it could be substantially less than that as well. Different view of that western fissure, building a nice spatter cone around itself here, plastered against that wall of the crater, that western wall, and open towards the active lava lake. This stuff is silvery in the foreground. This is all liquid lava. This has that thin layer of crust that in the daytime holds in the orange color. You don't really see as well. At nighttime, that skin is so thin it glow. You can see the orange glow through it, and then brighter in the cracks between those plates as well. That's what we're seeing on a thermal camera when you see all those polygons of different different sizes and shapes surfacing the whole lava lake there. Okay, this one's also giving us some more information. Using a laser rangefinder, field crews estimated these fountains are reaching heights of 10 to 12 meters, 33 to 39 feet above their base. So that may be a little more useful, 10 to 12 meters above their base. There's the base, 10 to 12 meters is up here. And so, I mean, really, it's hard to tell where the actual hole in the ground is in here, but to me, if it's in here, you might be looking at 3-4 meters above the lava lake surface, something like that. So interesting to think about that. You know, if lava lake is going to keep rising, and it's doing so less quickly, but at some point in not too long, right, we're going to see this flooding this vent, which is not unlike the north vent, the initial vent of the 2020 eruption, which within 1 week, well, within 6 days actually, was drowned and stopped erupting and shifted to a higher elevation vent afterwards. I'll come back here. I know we're almost done here. I've been going for a while, a little extra content for you guys today since there is so much from USGS, and what we might do is take the weekend off unless something spectacular happens here, and put out just shorter videos or text updates kind of thing, and come back to you guys and summarize the weekend. Because we're really piggybacking on USGS. There's all USGS photographs here, and if they keep putting them out, we can continue covering them more frequently, but that may not exactly be the case. See question come in from Volcano House. You don't really can't see the actual lava lake surface itself. You can see the reflection of the glow on a back crater walls. And Volcano House is really nice because there is a down drop block on this eastern side over here, which you really can't see from many other places. But from Volcano House, you're looking straight on at it, right? This is something that my daughter looked at, and she called it Pele's throne. I don't think that's actually what anyone else, I've never heard anyone else call it, but I was like, yeah, that really looks like Pele's throne right there. So there's the seat of that throne, if I may call it that today, right over there. Might be slightly more this way actually. Not that I look at it yet, but that's that back area that's brightly lit up from Volcano House. And so, like I said, different magic from every different perspective. And if you have time, you know, go and work your way around and get different views from different places. Especially if you're waiting for things to quiet down, thin out a little bit towards if it's busy in one area or another. All right, so this is that overview, mentioning the gas once again, and a slightly higher perspective. Now we're looking back to the west. Mauna Loa is back here underneath this cloud way up there. But better view here. You don't really see the edge of the down drop block behind us. So it's all the collapse pit right here, and the caldera floor goes on beyond behind the photographer. And really you can see the perspective there. In this photograph, since people are asking about, you know, where some of these cameras and things are, right? You can see the Jagger Museum, this building right over here. That's the Jagger Museum on Wikahuna Bluff right there. Right, that's the spot people are looking at and looking down more or less in this angle and looking at that lava lake rising in the back over here. So that's where the tower cameras are, right in there. The KW camera is somewhere around here. Very roughly, I haven't been out there, I'm not allowed out there, but given the perspectives, it's right around here, pretty much above this western vent, right in there. That S1 camera is likely over here somewhere. I'm looking from the south, where you see that fissure on the left, right? And now our view from that angle is probably something like this. And we're actually not catching a whole bunch of this side of the lava lake anymore. That's that S1 camera, and if I scroll it over here, you can see here, this is that lower ramp, that's that bay, that's the lowest spot, right? And above that is where the B1 camera is. The B1 camera is likely over here somewhere. I had to guess, right in there. And you know, if I zoomed into it enough, maybe I could see something, but maybe not. Go back. And that B1 camera, where was I? There. That B1 camera is looking off in this direction like this. So that west vent is at the far back side of the top of the image, right over there. There's a little bit of orientation. All right, I think we're almost through the photographs here. And we are gonna point out a couple of last things after the USGS photographs, but we are wrapping it up here shortly. The lake has risen 27 meters. The fish are opening along the floor. We're gonna keep going past that one. It says the line of lava fountains may have been drowned by leaping lava lake, with only a few low fountains still visible in this foreground area. And we've mentioned this whole pistoning of the former crater floor, so that may have something to do with it as well. I'm going to keep going because there's still a lot of photographs, and we've had a couple of long days here, so I'm going to try to wrap it up here pretty soon. But you see that lower level fountain coming up through the lava lake right there. They're lower levels on the edge of that big island. And interestingly here, you're starting to see almost like a perched pond effect at the edge of the island right over here, right? With like a little spillover flowing into a little depression right here. And it happened before. You can see another little flow right there. So there's a little bit of a perched barrier that happened right around here, around the edge of this island as well. It's interesting. Another aerial view. You can see tons and tons of photographs here. Another view showing those southern fountains, quite a bit smaller. This is that one that was going up to 100 meters, so it's quite a bit lower, even though it's continuously persistently active, I should say. And spattering to heights of 5 meters, 16 feet or less, right through there. So it looks small. That's still 16 feet tall, that fountain of lava. All right, here is another view of that lake margin with those plates. And what did I do? You guys are starting to see some user error coming here. All right, let's try this again. I want to zoom in on these plates to show you guys. So I'm going to click through to my original and go all the way to there. All right, so now you can see this levee effect, right? This is higher on this side than on this side. And this is the barrier made up of these plates of pieces of this crust of lava, right? That are just stacked over and over and over. And then the lava injects into them and essentially welds them all together. And that forms that cohesive barrier. And wherever overflows and overtops it, then you also get another layer of veneer and plastering essentially happening there. So that's that perched edge of the lava lake once again. Let's come back to here. Aerial photo of that western vent. Okay. Another one of the western fissure. Another one of that wider angle view, now from the northwest. So they were flying all around, photographing from every direction. That's what you need to make a really good structure for motion model. And here finally, HVO gas scientists taking notes on a spectra being displayed on a field laptop, right? So gas measurements going on here. I think there's another image here, yeah, the FTIR, the Fourier transform. I'm getting tired, like I said. Fourier transform. Yeah, IR. I'm not gonna. My brain's stopping to work here now. So the measurement. There's shoot us through the gas plume here, and it can measure the gases here. So eruptions generating a plume consisting primarily of SO2, H2O, CO2, and SO2, but also halogen gases, HCl, and HF. Not good stuff. All right, I think that wraps it up for the USGS photographs there. So, okay, a couple things to mention. Hawaiʻi Volcanoes National Park is continuing to post images on Twitter, and this is our friend Janice Way. And she's photographing things all over the place, so check them out for more images. I'm not going to go through all the park's pictures as well. And just a reminder to you guys, especially those of you guys who are not in our Facebook group, to look on Facebook, HawaiiTracker.com, or Hawaii Tracker Facebook group, HawaiiTracker.com as well. But the Facebook group's got a lot more of the contributions from other members. You can see just right in here, there's 195 posts on Kīlauea, 91 Kīlauea 2021. So I'm not going to go through all the posts. Obviously, there's way too many, but you get some idea here, right? You know, of user photos. There's that VOG image, people capturing the webcams and posting them, particularly nice shots throughout the day. View from Volcano House. Someone was asking about that. There's a Volcano House view last night or this morning, perhaps. And there is a piece of tephra the USGS and HVNP are showing off. There are some other pictures of Hawaiian sites. Stars shining through the clouds above the glow. Rainbow and the plume with Kahuna this morning. I'm not going to go that much more. I'd like to see if I can get to Harry's and find Harry's in here. It may not come up for me, but perhaps I'll leave it there. Some historical stuff there. Paniolo, Hawaiian cowboys, the original cowboys before there were any cowboys in the quote, quote Wild West, right? They were here in Hawaii first. Throw that teaser out for you guys to discuss. And okay, well, I'll stop looking for Harry stuff, but there's something you can find on there, right? And once again, hawaiitracker.com, and we'll try to post more things there if we can, and encourage people to post their photographs and stuff there as well. All right, Dane, I think I am out of breath and running out of brain too.
Right. Yeah, we're gonna be going on 2 hours shortly. I do want to shout out the donations that we've been getting, because we've been getting a bunch.
Yes, please.
There's been a few in chat that I want to get to. The first one that I missed was 6 cents. Appreciate that. And there was a $20 super chat from scrolling for it. Joe Beth. The GIF actually covers. They put a GIF in there, and it actually covers up the name. But we appreciate those donations. We also have a bunch of donations to go through on the website. Just going to read them out real quickly by first name only. William, Daniel, Wendy, Melissa, John, Lee, Robin, Lori, Lance, Sherry, Margaret, Nancy, Jana, Robert, Jessica, Jaroslav, Elizabeth, Peter, Mel, James, Laura. I think that's all of them, and we appreciate everybody.
Wow, yeah, we're really touched.
Yeah, guys.
That's amazing.
That.
Thank you guys, and that makes us feel appreciated. This is a huge amount of work. I'm sure you guys can see that. We're trying to do it as you guys have the interest. Like right now when things are really happening quickly. So yeah, mahalo.
Right. Yep, and check us out on hawaiitracker.com. That is where we post most of our content. And we also post on social media, but if you want one place to get it all, that's where to get it. And check out the Hawaii Tracker Facebook group. I think we just went over 70,000 members there, and we were in the Facebook group, and I think this channel is about to go over 5,000 subscribers really soon as well. So appreciate everybody for sticking on with us and maybe learning something from Phil every once in a while.
Yeah, and just from discussions and the questions, I'm not a know-it-all. I've read a lot of stuff, and I can tell you what the factors are most of the time, and what goes into the decision, or what we think about. And that's the fun part about it, is thinking about it rather than having a 1 + 1 is exactly 2, right? I'm gonna say, well, I'm gonna tell you, it's between 1 and 3, right?
And one other thing that allows us kind of to do it is we focus on Hawaii Island. We get a bunch of questions about right now the Canary Islands or Iceland, but it's we keep telling people like we're only really doing Hawaii, right? We might talk about some other volcanoes on occasion once in a while, but don't count on it. And if it happens, it happens. But that's not what we're here for.
I mean, I really wish that we could expand in the future, but we need more people. There's just no way. there's RT volcanoes, as you can tell, are plenty to keep someone busy their whole life. Right, so we'd love to collaborate further, and we hope to be setting an example as well for people to have this kind of broadcast in other volcanoes. And we've heard of some, and we haven't had a chance to really check things out in too much detail. But I appreciate you guys sharing those, and maybe if you do find someone who's saying something else nice, you can share our channel with them, and then theirs with ours back here as well, for our other viewers interested in other places as well. Right, I can mention that I have in the past worked with Volcano Discovery. So somewhere else you can check volcanodiscovery.com for all the other places, and they have correspondents on the ground everywhere, of which we sometimes contribute for Hawaii. But really our focus is more on our community, local community, and communicating to them more directly at this point in time.
Definitely. What I was going to explain a little bit earlier is we were featured or Hawaii Tracker was featured in a new documentary that just came out today from Vice News. We are going to I'll put a link in the chat right now if you want to check that out. No Drones On again this week, but they did a really good job with that documentary. They took a lot of time with it. Interesting crew, and it's always a challenge to get people that don't really know the island, like a film crew or something like that, in the mindset of how to really talk about the island. But I think they did well. it's really a challenge to get like the little nuances of the cultural stuff right, and they got most of it. So I was really really appreciate the effort they put into that. And so yeah, shout out to Vice News, and check out that. It's about 15 minutes long, not too bad.
Yeah, 18 minutes long. Yeah, here's the title of it, Weathered. It's on the screen. Yeah, with Katie Tutrone. And Dane's got a link posted, and if it's not yet on HawaiiTracker.com, that may be where the link is taking you.
It is.
I've been talking for 2 hours, so I haven't had a chance to look. But yeah, you're weathered, and I don't know if I can find a clip here, but Dane is in this. Dane's perhaps modestly, but
erupting volcano.
Why would you build a house in an area that's prone to wildfire?
I would take a volcano disaster over any other disaster any day.
It's very.
That's just a little teaser right there. I'll play a couple of seconds of it, right? There's a lot more later on. That's just the intro sequence right there. So, someone was asking yesterday, like, "Oh, you guys, we really appreciate what you guys are doing. How come you guys are never on the news or on TV?" And so, like, there's Dane on TV, modern version of it, yeah. And you guys may have seen me on Hawaii News Now or KITV here in local Hawaii news as well, broadcasting over the air. So we do like to branch out, but we don't make sure we reach all of our audience as broadly as possible. And there's people on this island who don't get TV out of Honolulu, so that's really not our local audience when it comes down to it. So yeah, there it is. Yeah, check out that.
Yeah, check that out.
That Vice News. I think maybe I can scan the questions here real quick. We got a USGS.
Yeah, I do have a few lined up if you're ready for those.
Yeah, go ahead. Yeah, and I'll scan some too.
So Karen asks, how high is the lava compared to... Oh, no, I think I got that one already. Let's go down to this one. Okay, so Christina asks, the VOG is pretty terrible over in Kona today. Our subdivision, I think she's Kona Palisades. Our subdivision read 106 on probably the particulate matter would be my guess. I'm not sure, though. Phil, isn't the worst right at the beginning, and then this might settle down a little bit? The hopes of a lot of people in Kona.
Yeah, absolutely, right. So like there's a lag between what happens at Kīlauea and the wind blowing it around to the Kona side, and there's also a lag between it getting cleared out of the Kona side. It usually takes some the winds shifting or a big rain event to really wash the air clean, right? So there's a couple of things happening there. So first, we had a quick burst at Kīlauea. We know that the first day was 85,000. We know the second day was 20,000, 1/4 of that rate already. So it's going down already very quickly. We'll see what the measurement is tomorrow. I'm sure they're measuring a lot more often than once a day. They're just reporting probably representative average to us. So we'll see if it drops down more and more and more. But that the message essentially is that it's like a big smoke signal that got puffed out, and then once it tails off, it'll just blow through Kona and the rest of the island until that next event of the wind change or rainstorm washes it out, and then we should be good until the next eruption kind of thing, or the next phase of the eruption, or we'll see what actually happens there, right? Because we're presuming the gas is going to just tail off here from what we saw in the last couple of days. That would be typical and consistent. Yeah, but still, you're still looking at probably a week of suffering through it, unfortunately, no matter what.
Yep.
Yeah, at the least.
I like this next question, and we discussed it briefly, I think, off air. But Kenny asked, "Do you think the islands that are in the lava lake will start moving around the lake?"
Yeah, great question. Let me pull up the thermal one more time because I like to look at it, and it's a good chance to talk about it some more. So there it is. And this is where that last thing that I was talking about when I was moving this back and forth really quickly and showing all these things moving up coherently, right? What I'm essentially saying is that we were seeing just a peak. If I were to draw a profile of this and put it in yellow, you'd see a high spot in the middle, but you would see a crust that goes all the way to the sides, right? So something like that. And so the question is this middle island detached and is it floating above it, like apart from the crust? Or is really the whole crust going from here to here? And it seems like the latter, like the whole thing's moving up together, because it seems like these don't seem to move at all, and they're all moving upwards together. So I think they're also connected at a shallow level. Now, if magma keeps bursting through these cracks through here and is able to break these blocks into smaller chunks, then maybe you could have some of these pieces start to move as well, right? The other thing that happened before in the last eruption was the actual cinder piling up near the vents, like right here, would get caught in a lava lake, and that's when you start seeing more islands form as well. So once the lava lake rises to start consuming some of the cinder cone, you might see more of that as well. Yeah, good question.
Yeah, definitely. Nicholas asks, have volcanologists been able to sample the magma from the new eruption yet?
Yeah, absolutely. We haven't had results of the chemistry yet, but all that tephra that flies out of the pit in the ground, that's the sample you get. You're not going to go rappel down in there to scoop out something fresh just because it's fresh. You let it come to you.
People envision that there's some dude dressed in all silver doing a Mission Impossible rope swing down there, to get a sample with a pickaxe or something, but it's a lot. They just go pick up something off the ground that flies out of there.
Yeah, that's like the dramatic National Geographic, I'm trying to get some airtime on camera and film my film contract way to do it.
Right.
Right, and that's not how it works in Hawaii.
We do have 2 more donations on the hawaiitracker.com/support. James and Diane, really appreciate it, guys.
Mahalo.
And I'm basically out of questions at this point.
Well, that's fine. I'm
sure
probably
we can
out of
try
breath.
To keep going all night, but yeah, we are at exactly the 2-hour mark. So
yeah,
this is as good a place as any to end it.
Yeah, let's cut it off. Yeah, and so I think I'm gonna make the call here and say we're gonna take the weekend off and just do other shorter updates. And we'll come back with another live, maybe on Monday, maybe on Tuesday. We'll post an update on our channels and on Facebook to let you guys know and other updates as well. But depends how much. If USGS is releasing things throughout the whole weekend, we'll have to catch up on Monday because it'll be too much to wait beyond that, right? But we'll wait and see how it actually goes and announce it to you guys. But until then, you can follow us on hawaiitracker.com, Hawaii Tracker Facebook group, and we'll keep putting out these shorter videos as we can on YouTube as well. So mahalo, everyone. From hawaiitracker.com, he's Dan DuPont. I'm Philip Ong.